Hello and welcome back to the CAS Inspire. This webinar is called using, I don't think this is the right one here. It's not using Seesaw on this. It's the A Level, let me get it right, the A Level How to Use Python Visualization to know more about climate change. Looking at cross-curricular lessons within the Teach Computing curriculum. So my name's Simon Howe, I'm hosting the session. I'm joined by my colleague Leah, you can see up there, who'll be watching the chat for any questions. So if you feel like you need to ask questions, please post them in the questions tab, because she'll be moderating. During the session, again, questions in there are moderated. You listen only, so you can't interact, so you don't look to take your mic off or anything like that. Please use social media for the hashtag at CAS Inspire. So without further ado, I'm going to introduce our panel today and this afternoon. So I'm delighted to be joined by Thomas, Peter and Julie. So Thomas works as an assistant head, digital at an independent girls' school in Reading. He's been teaching computer science and leading on digital learning for over 20 years. Julie became a member of Computing at School shortly after having her satisfied about addition of computing. Oh, sorry, let me just start again. I'm getting my words mixed up tonight here. Sorry, guys. So yeah, Julie, I know Julie quite well. She's a great with the NCCE, the National Centre for Computer Education. She's a CS champion for that as well, so really knowledgeable. So I'm really looking forward to see what Julie's got to say. And lastly, Pete, who's obviously one of our outreach managers as well, insanely knowledgeable about lots of things, you know, great advocate of things. He's also part of the NCCE Computing Hub, part of the EU Coding Week ambassadors, and also been heavily involved with the Safety Week, which is coming up on the 8th of February. So without further ado, my bumbled first speech there in there, I'm just going to hand over to Julie, who's going to go first.
Hello, thank you, Simon. I hope you can hear me. I'm sure that somebody will tell me if you can't. Now, you're probably wondering, why have I called this part of the presentation Exploring the Potential of Python Data Visualization within Secondary Education? Because this is an A-level focus. Well, it may well be because I am really a secondary specialist, but it's really good to see where your students are coming from. That's one of the reasons, but it'll become clear as I move my way through this presentation. So if I explain, green computing. Green computing is a problem-based unit which I constructed for a year 9 class. At the time, there was no data visualization included in this unit. Now, I'm going to go on to the next slide, and this shows you the basis of the unit, and it's based on a particular pedagogy which I was working with at the time and developing. So for the green computing, the rationale was that it was to, I won't read exactly what's there, but it's thinking about the students in terms of not GCSEs, not A-levels, not national curriculum or whatever, but just thinking about the students and how applicable it is to them. And I liken it to the intent in the Ofsted framework, 2019 framework. So it's thinking about them and their place in this digital world that they are going to be inheriting. Thinking about not only the things which can be improved thereby, but thinking also about the opportunities and threats. In particular, what happens to these redundant digital devices? Now, the hook for this was a video, a very emotive video, which ended up with some of the students actually, you could hear sobs at people in a very poor African community burning digital devices, hitting them, getting the raw materials out, and in the meantime polluting the watercourse, etc. It was quite emotive, and the outcome was going to be a website. Now, where on the earth does this digital element, this visualization in Python come? Well, it wasn't there to begin with, and I thought to myself, well, we could actually add something in, although it's not A level, we could add something in that extends the students' Python programming. So that here we've got on this slide, it just shows the pedagogy behind this unit. But if I go on to the next slide, I had not actually attempted data visualization in Python before this time. And so I've just included here some the online resources which I found very, very helpful indeed. A member of my family says that you can do anything if you have access to the internet and a certain amount of intelligence. And so this is what I lighted upon. It's Geeks for Geeks is my go-to. There are other websites, of course. Now, how am I going to integrate data visualization within green computing? And this is what I decided to do. One of the important things, as I said, was to extend the students' understanding of Python and what they were able to do with it. So you can see the sort of structures that I've got here. Essentially, we've got here is the GDP for certain countries. There we go, GDP. And if I remind myself, it related to GDP in the States, this country, I think I included China, Africa, and there was one other country, which you will see in a moment, no doubt. So there were these three sets of data which I created. Oh yes, there we are, country, US, UK, US, India, China, and Africa there. And I included some data which is totally inaccurate. And as you see here, I've left myself a post-it note replaced with real data. So in actual fact, this is a work in progress. It was just, how can I include data visualization using Python in this unit? Now, this is what I was so pleased with myself when the first time I created this code, it actually worked. So this shows the GDP, the population, and the amount of digital waste disposal in these particular countries or continents over this period. Now, the data is not correct. The conventions of data representation, so the headings are not correct here. But as I say, I just wanted to show you this as a work in progress. Now, why? If you remember from the third slide, it did actually mention there that in terms of curriculum, we were looking at each of the strands in computing. The lead was digital literacy. The lead 2 was computer systems. So we were thinking about the components which make a digital device. And the third one was applying their hypertext markup language skills. I can never say that acronym, so I avoid it now. And so they needed to collect data and present data. Now, if I had thought of this at the time, this would have been a great addition, because then we could have collected the data, represented it graphically like this through Python programming. So it's actually perhaps at the top end of what you would be expecting the students to do at secondary. So where am I going to go from there? I had exhausted Geeks for Geeks for my purposes. And so I had a look on the internet and found this really rather good resource, Introduction to Data Visualization in Python. The only thing is I don't agree with the Z, I much prefer the S. Now, this is what I started to do, and this is where I'm going to continue from here. So I've set up a dictionary, yes, and here's the code, yes. So as you see here, I've just created these numbers. It's not based on real data, but that will come at a later stage. Now, that data I'm so pleased with myself. This worked first time. Created this. Well, I've been using my MacBook, but this is a numbers folder, but or file, but I can actually export it to Excel. But my next thing is to see the different ways in which I could present this data or expand upon it. So it is a work in progress. It's just I was thinking, how can I use visualization using Python to enrich, to strengthen an existing work? And what next? I'm going to amend the bar chart programming and then create the more sophisticated visualizations in the CSV file. And then I can explore how those more sophisticated elements I can include in the green computing unit, with a mind to extending the higher achieving students. And that's the end of my presentation. And I'm going to pass over to Pete now, and I'm going to be Pete's person who moves on the slides. So here we go, over to Pete.
Brilliant, thank you, Julie. That's great. Yeah, thank you. So I'm just going to do a short piece here just to talk about visualizations a little bit and kind of libraries that you can use for Python. I've kind of used them with A-level students doing their project work just to add that extra kind of little bit of excitement and, you know, visualizations and interfaces and stuff like that. And because we're doing something around kind of environment, I thought I'd kind of keep that context. Some of you may have seen bits and pieces like this before. But Julie, do you want to move on to the next slide? So we're going to do it on wildlife poaching. So reasons that I guess we should care about this. I thought it was important to have some context first. So, we're obviously, really caring about extinction of animals. I think it's a good topic to kind of start with. It's great to get data because you can go to WWF and use their massive data sets. Now, I haven't used a massive data set for this one, but you can do. And of course, in terms of, the economy, the corruption that it brings, it's a great topic to explore. So I use this as a topic to get the students talking about it. And then we just do a little project. It normally takes a couple of lessons, do some visualizations, and then they take those ideas and they embed them into their NEA work for A-level. But I've also done it with GCSE students who have kind of wanted to take their NEA a little bit further. Thank you, Julie. Do you want to move on? Excellent. So I wanted to kind of break down, because I think when you're looking at these libraries in Python, it's very easy to get very confused, and I've tried lots, I've experimented lots. So these are not the only way of doing it, but I hope this provides you like a starting point if you've not done this before. So there's a big library called pandas, right? Which I know we're talking about animals, it's not those type of pandas, but you can like create loads and loads of data. You can do lots of data manipulation, but there are libraries that build on the Panda library to make it more accessible, because pandas is a big, massive thing. So X-ray is something that I use where if you've got some data, if it's like, if you've got like, really complex list structures, or you've got linked list structures, or you've got arrays, if you're importing array libraries, you can still do that in Python, which is actually quite useful when you're doing some of the data sets. You can actually add attributes, which is really, really useful. So you can add things like dimensions, coordinates. So imagine you've got some data, but you don't want to add lots of extra kind of rows and columns in your data set. You just want to apply object style linked attributes to them. You can add things to them, which is great. So you're just kind of like adding little labels to your data. And that's really useful, because when you come to do the visualization, instead of you having to manipulate a massive set of data with lots of rows and columns and attributes, actually you can just access the pointers to those values. So which takes me on to the next bit, which is, I don't even know how you say this. I don't know if it is NumPy or NumPy, I don't know, but NumPy sounds great, right? So NumPy is another one that you can use, and there's a library within this where you can use pie tables. So this is where if you've got massive data sets, it makes it really easy to search and manipulate that data. So imagine you've got like a relational database that you've created and it's got mass data in it and you want to search it. It's basically a much more efficient way of doing that. So you can just take massive data sets and you're almost doing a bit of data mining. You're using the module to search for data more efficiently. So you're less worried about the structure of your database or your data set. You use this module to kind of do the clever, efficient searching of your data. So those two things, I tend to start with the X-ray first, then I might search that data to bring out something that I want, and then I do the visualizations, which we'll come to next. So Julie, do you want to just move on for me? It's great having you help me do this. This is brilliant to do this. It'd be great for the classroom as well, wouldn't it? Visualization is there are two ways you can do it. There's Matplotlib, which most of you probably would have heard of if you've done any visualization. It's been around for a long time, and you can do super quick, simple visualizations, but it is a massive library. It is actually very, very complex. The one that I use is Bokeh, and again, I don't even know how you pronounce it, Bokeh, but this is really, really good because what it allows you to do is make interactive visualizations. If you imagine you've got like a line chart or a bar chart, as you hover your mouse over it, because it basically renders it in HTML, you can hover over it and it will tell you the values, or it will tell you that point value on that line, which is difficult to do with Matplotlib. All right, so Bokeh is the one I'm going to show you next. And at the bottom, I've just kind of gone through the process I use, which is load the data into pandas, investigate with pi tables, take that data out, and then use Bokeh to present the graph. So what does this look like? Julie, do you want to just move on to one more for me? What does this look like in essence? To be fair, it took me longer to draw the GIFs of the rhinos and the elephants on this than it did to do the whole thing. So this is a challenge I set myself. So I just downloaded some data off the WWF website. You can see the code on the right hand side if you're interested in it. I'm not going to talk through that, but effectively you can see you get these lovely visualizations on the left. You can even put a lovely little backing image. I just put like a South African background on it as well, which I think is quite neat and tidy. And then on all the plot points, you probably want the elephant heads next to each plot point, but I kind of thought it was something I wanted to challenge myself. But I had to do a separate for loop to get that to work. I'm not sure that's the most efficient way of doing it, but I couldn't get it to work any other way. So there's an example using Bokeh, but there are many different visualizations. I've done quite a few on heat maps. So heat maps is a really exciting thing to do if you've got coordinates or you've got GPS locations. You can do some really good heat mapping in graphs as well. Do you want to just move on to the next slide for me, Julie? I think that might be it. Oh, yeah, that was the final bit. I think this is on the CAS resource section. You can find it. I've made a couple of these for line graphs, heat maps, bar charts. I think I've got like 5 or 6. But I've kind of like done it into stages so you can step through it. I wish I kind of did these when I was doing this with my class the year before, because we just sort of did it a bit ad hoc, but these are quite good for your classroom because they can actually work through the segments of code, understand what they do, and it's just like a simple kind of cheat sheet for it. But of course, you'd edit it and do the extra bits and pieces. So I've got some of those there on the CAS resource section somewhere. That's it from me, Julie. So I'm going to hand over to Thomas, I think, who's going to be talking you through some further things around visualizations and data science.
Right, you should see my slide by now. Is that correct?
Yeah.
Excellent. Okay, so yeah, I'm going to take it a little bit further, and very good what Julie and Peter outlined already of how you start and get going. So I'm going to introduce you to another Plotly, and that's what comes really nice with the how you represent it. So once you know where your data is and everything else, Plotly fits in really well in producing some really clever output of that. And also it renders it even into reports. So you can actually not only HTML and what Pete said as well with regards to hover over it and get the individual values, you can actually then create reports as well. So these are a type of selection of charts that Plotly has built in that work really well. And here are a couple of really good projects that you can look in, and there are actually some walkthroughs as well. So this is from a guy at Oxford. He just finished his PhD in mapping and data analysis, and he's got a website and Twitter handle called Python Maps. and he basically looks well, and this is mapping, for example, all the rivers and their areas where they draw the water from in Africa. So it explains where the data comes from, what you're putting in, and what you look in Python to connect to it. So really easily done. And I think the point that we are getting to, and I must admit, I mean, I've been teaching Python now for a few years in the lower school as well. We're introducing them in Key Stage 3 now. Then in Key Stage 4, we are with Cambridge International for the GCSE, and they have Python as their main body of the pre-release material, the coding side. And then we do OCR A Level here as well, where some of the students are looking at some of these programs now as well to do. And I think the benefit is with Python as well, because you can do so much with it now. And I think this whole mapping side I think it's to be discovered a lot more, and I think makes it interesting as well. Especially when you show simple examples of how you can scrape websites for the information as well, and especially with COVID and everything else, there's so much data there that is readily available to just take off the internet to visualize then as well. So this is one example that works really well, and the power of the data comes through as well. Another example here is the life expectancy around the globe. With all the countries, you're literally just pulling the data there as well. You get a nice, easy way of figuring out of how to present it. And then the beauty of it, at the bottom, you actually see a slider here. So you could, if it was a live demo, you could actually slide through and see how all the colors change every 5 years through. So you set the scale and everything else, and it shows it nicely through as well. And basically, it takes the data and puts the different layers on top of it, filters page by page through as you go through. And that's the power of Python these days. That is really impressive. Again, here with the data overlay of geographical data, that could be related to where instances happened, where you have flooding, whatever you want to make out of it. In the bottom right, you see the temperature distribution, the precipitation in the States on a certain day. Again, all the data comes from publicly available data sets as well. Again, that's another easy plot that Plotly allows you to do. Again, pull it in, give it a bit of background of where what you want to have with the scenarios there, and it does it. And what I feel like is this is where I think the data is so powerful. Here's, for example, on Google now, there's another sub-site that is called data set search, and it basically gives you all the data sets that are available. You type in any topic, whether it's COVID-19, whether it's, in this case, I use climate, and you'll see all the data sets that are somewhere in the world available, either from educational institutions or from different governments around the world, and it has them all linked. So it's a super duper power search engine from Google there, and any of that data, it gives you even the headers of what it has, so you can copy those headers into Plotly, or even if you and everything else to manipulate it even further in advance, and then suck it in, and you get some phenomenal data coming through that way as well. So there's a whole bunch of really interesting ways of visualizing it, and I think the power is that the students will actually appreciate it a lot more. And I think the context that we need to give to the students as well is that at university they will need those skills. The amount of time that I've now heard from students that have gone off to university, whether it's in psychology, whether it's in biology, whether it's computer science, whether it's in physics, even history, they are learning how to use Python in their first year to do big data analysis. And I think that's what we need to hone into as well as somebody in the school maybe that provides the digital skills. And I think the data science side will grow phenomenally over the next few years. And I think we're at the forefront of pulling those resources together and making them happen there, very much so. Just to show another angle, so this was climate related, and again, the data is all the same in the end. But there are also very, very interesting projects that are available to us to join up. So, for example, this was one from a couple of years back. The Queen Mary University, their physics department, actually made those data sets available to hunt for exoplanet. So you were actually writing Python code to understand how you hunt for exoplanets, and then you run it through the data sets that you got and got the information, and you could identify whether you could see any exoplanet. But that was a real problem that they introduced from NASA, and saying, if you're a scientist, if you're a physicist, you actually will go through all of those processes. To my, not surprise, but as a confirmation of the whole process, one of our students is now doing astrophysics, second year at university, and she went through exactly the same process. They actually were told Python is the main language, and then, by the way, you're going to hunt exoplanets. So we introduced this 2 years ago as a project here in school to go through this. But there are so many different data science projects, competitions out there now that are really, really important, that people can hook up to, and it becomes an interesting area for students as well. So where does it leave us? Where could we do those projects beyond climate? Geography, and our geography department is very excited about it, and they would like to look into it. The first thing I see is it's almost like a lot of it will be happening post GCSE. And in my case, I would try to build it into the EPQ. So if you have a geography EPQ or a science EPQ, I would love them to consider doing a Python data project as well with what we just discussed. So they can then write it up really well and everything else. It could also, and again, that's what we're looking at from next year, building it into the lower 6 enrichment classes, as in just digital skills, that everybody has a chance to go through sets of data and looking of what Python can do with it, even if they don't understand Python fully, but that we're building something that they can play with and see that there's an opportunity, and hopefully people get excited about it. And by the time they write their personal statements a year later, they will actually say, I've done some of those essential skills already. Coding club is obviously an option there as well, and some of our upper 6, lower 6 are getting involved in working on some of the codes with it. The other thing I think will happen a lot more are competitions where data science is a topic, and Team Tech started a couple of years back now that they have a Team Tech subsections where you will be given data sets, and then you analyze it. Principally, people will use for it or similar spreadsheet software, but again, that would be a really nice way of maybe introducing somebody to Python and see what they can evaluate there. And the other last one for us is in OCR A Level for the NEA. We're definitely looking at data projects next year in Python, because you cover all the essential elements of the marks needed, because either APIs or scraping it off the website. So you're importing the data, then you're manipulating the data, you're making sure you're writing code for a purpose there as well. So we're hopeful that one of our students will go down that route as well again, to one is get more knowledge ourselves, but also building a portfolio of projects that they've done. I put all the links on this page, so for all the different slides that you have. So once this is finished, in the slides are available, you can happily click along on that. But that's all from me. Thank you very much.
Excellent. Thank you for the great, insightful world of Python and visualization, and some really intense bits of coding there, which is great. I always love learning sort of bits, put me out of my comfort zone a little bit, you know, into my niche, and some good things to sort of check out there. So some really good points. I don't think we've got any questions. So do you have any questions for each other as the panel, or are we all happy?
I've just got a quick one for Thomas, really. So sort of, Thomas, you were kind of talking about, you know, the modules you use and your ideas for moving them forward. So how do you kind of fit this in lower down the school? Is there something you're kind of before A Level thinking about bringing in early to kind of get them thinking about this stuff as they get towards A Level?
Some of our girls do EPQs, so sorry, the lower school EPQ, the HPQ, and we're looking at some of those that are interested in coding, of whether they want to get involved in some of those, writing some of those up and saying, can we import some of those data for climate, for any topic they like, really, and working through some smaller projects. But I think it is really, at the moment, it is such a specialized area, because I think, like all Key Stage 3 computing, we struggle to even get them to do the graphs and stuff as a class activity and get that going for everybody. There will be a few people that get it very well, and I think I would like to build on those few that get it very well and get excited by data and data representation, to find a way of saying you can actually move on to something that people use in real life at university and everything else. And I think that's where I think over the next few years, maybe in 5 years, we will talk very differently about data science in school. But I think at the moment, we're really in between very basic information and very basic data manipulation versus of what we could do already, and what some of our recent undergraduates or people that are now at university all of a sudden need. There's a huge divide between what we provide at the moment and where they need to be. And I think that we need to find projects, we need to find ways of engaging some of them, that it becomes more normal that we have those projects around in school. And I hope competitions from various places will encourage that as well, that it becomes an easy way of saying, hey, you're good at this, would you fancy having a shot at this competition, for example?
Yeah, that's great. And also, big data at the minute is sort of massive. I know it's a big growth area within the industry, and people just trying to get people who can understand it. So yes, it's a really topical thing to look at. Well, obviously, thanks for the session today. So thank you for Julie, Thomas and Peter, some really insightful work there. Remember, can you please use social media to tweet all the wonderful ideas that you've learned today at the hashtag CAS Inspire. And that's it for us. So thanks a lot for tuning in, and please join us next week for our next CAS Inspire session. Thank you and goodbye.
Very much.